So now you've seen probably around 6 proofs with evens and odds, and this is very, very similar to even plus even is even, right? We're just going to make one of the evens negative this time. In fact, you could say this is the exact same proof as even plus even, because negative even is just saying plus negative even, right? And our proof is the exact same now. So what I'm going to do is I'm just going to, instead of going through the steps in detail as I did in the first, I'm just going to go through this very quickly. I'm going to briefly explain my logic, remind you of the definitions, and write out my proof. So you can test yourself this is true. I'm just going to tell you it's true, but you should see this. Think of some examples. It's really hard to think of a counterexample, and like I said. So anyways, what are we saying? We're saying for all a plus b that are integers, a and b, if a and b are even, then a minus b is even. Awesome. That's the statement we're trying to prove. This is our q. This is going to be our p. We're going to suppose p to prove that q must be true. So this is a for all statement. And what are we using here? We're going to be using the definition of even, because that is the only thing in this statement that we need to know. So even is just any number x, that's an integer, such that x can be written as 2k, where k is also an integer. Awesome. Now we can start writing our proof for all, which means we start the very first word of our proof as let. We're going to let a and b be integers, because remember, we're going to pretend like the reader does not see any of this. This is the first thing they're seeing. We're telling them a and b are integers, such that a and b are odd. Great. Now we need to be more thorough with what we mean by odd. We're going to say, suppose a is equal to, oh, I'm sorry, not odd, even, my bad. Yeah, okay, awesome, that's perfect. Let a and b be integers such that a and b are even. Suppose a is equal to 2m and b is equal to 2n, where m and r integers. Great. Again, this is almost identical to our even plus even is equal to even proof. Next, look at this. We're going to say, therefore, comma, a minus b is going to be 2m minus 2n, which is really just going to be, let's factor the 2 out, 2m minus n. There we go. And what do we see? We see where m minus n is an integer. This would be our k. This is our x. So we're saying this 2 goes down. X is equal to 2k, right? This should be pretty obvious now. Now we just write our concluding statement. Since a minus b is equal to 2 times m minus n, where m minus n is an integer, a minus b is even. Awesome. We've proven this statement. Wasn't that much of a leap from our first proof.